Please note that these video tutorials are meant to be companions to the Series 5900 operating manual. While we intend to explain instrument operation as clearly as possible, refer to the manual for additional information and details. Before starting up the Series 5900, recheck all connections: gas, columns, power, and signal. Turn the power switch on at the rear panel. The LCD touchscreen will boot up and display the main screen. The main screen provides the local controls to ignite the DID, set the temperatures, zero the baseline, select the range, and control the valve positions. The actual values of the discharge current, polarization voltage, and the instrument status are also displayed. The menu button provides additional controls to set the DID start or DID run voltages, polarization voltage, gain, and valve remote lockout. You can also update the firmware and load and save settings from the menu button. The flows must be manually set before any operation. To set the carrier flows, make sure all the gas valves are in counterclockwise (CCW) position, indicated by blue color on the valve buttons. Refer to the instrument flow diagram to measure the helium carrier flow rates at the outlets on the back of the instrument. Set the recommended or desired flow rates by adjusting the manual bellows valves on the front of the instrument. All helium carrier flow rates are recommended to be 30 milliliters per minute. The DID helium flow rate should be set at 10 milliliters per minute. Turn on the purge helium gas flow on the front of the instrument and check for the recommended flow rate of 30 milliliters per minute on the back of the instrument at purge out. This is factory set but may require adjustments after installation. A constant purge helium flow effectively masks microleaks in the system, which improves analytical accuracy and reproducibility. To avoid any damage to the column and the detector, do not exceed the maximum operating temperatures. Maximum temperatures of the columns vary based on packing material and are listed on the column tag. The maximum DID temperature is 120 degrees Celsius. We highly recommend continuous carrier flow through the column and the DID at any time when the set temperatures are above the room temperature. Setting the temperatures for the column and detector can be done by pressing the Set button. A keypad will pop up on screen and the desired temperature in Celsius can be entered. Press Enter to set the valve. The set temperature is displayed in the Set button, while the actual temperature is displayed in the Actual box. Once the set temperature is reached, the Set button will turn from blue to green. Provide adequate time for the column and the DID to reach the set temperature. Allow 2 hours for system temperatures to stabilize after the last set temperature is reached. The terms ignite and lit are used to describe the presence of the high voltage arc that ionizes a gas sample. A stable arc is essential for instrument signal output. Upon initial startup, the DID voltage button will be green and the text above this button will read Run, indicating that the DID is ready. Look for the discharge current in the discharge milliamp box. If the milliamp reading is less than 4, the detector is not lit. If it is not lit, it will be necessary to ignite the DID by pressing the DID voltage button. When the DID is lit, the discharge milliamps will go above 4. Return to Run Voltage by pressing the DID voltage button. Notice the change to the displayed actual voltage. Ultimately, the start voltage should read 750 volts, while the run voltage should read 525 volts. These two factory set values are recommended. If you would like to change these values, there is an option to do so for the DID high voltage. This is done by simply pressing Menu and entering the code number 1 for start voltage or code number 2 for run voltage. Press Enter to set the new values. After the DID is lit, monitor the discharge current for the DID. The discharge box will read between 4 to 10 milliamps during normal operation. Polarization voltage exists between the signal collector plates in the DID. The lower polarization voltage, or pole voltage 1, is factory set to 160 volts for standard operation and is displayed on the polarization volts box. A second and higher polarization voltage, or pole voltage 2, of 240 to 260 volts can be set if neon impurity must be included in the analysis. Pole voltage 2 is controlled remotely. Please note, extended use of a higher polarization voltage of more than 160 volts will damage the detector. Do not exceed 5 minutes when using a higher polarization voltage. To set or change the polarization voltage, press Menu and enter code number 3 for pole voltage 1 or code number 4 for pole voltage 2. Press Enter to set the new values. The detector signal displays the actual output signal to data collected in millivolts. Press 0 to bring the baseline signal down to approximately 0 millivolts.